Here we're going to do some guided exam question practice on the 2020 question from the Leaving Cert higher level paper that came up on Redox. It's a half question worth 25 marks. So the timing here is about 10 minutes. Okay, so we're going to jump straight into it. It says to define oxidation. So make sure we're talking about oxidation in two ways. First, in terms of electron transfer, and second, in terms of a change in oxidation number. So jumping over here, this was B in the question, and it was part one. We're defining oxidation in terms of electron transfer. All right, so pause the video, go ahead and do this. All right, so if you weren't able to do this, all right, here's your acronym for electron transfer, oil rig. Remember this from class. Oil rig tells us what happens to electrons during oxidation. Pause the video and write down what oxidation is now. Okay, so what you should have written is oxidation is a loss of electrons. So oil rig stands for oxidation is loss, reduction is gain. So oxidation is loss of electrons. All right, part two of that is define oxidation in terms of change in oxidation number. You know how to do this, pause the video, go ahead and do that now. All right, if you didn't know how to do this, let's take a look at an example. Say we have a chlorine atom, Cl, okay? It is an uncombined element, so think about its oxidation number. What will it be if it's an element uncombined? And Cl will become Cl minus. It's in group 7, it will gain one of electron to achieve a full octet, if you like. So now it's become a -1 ion. So what will this oxidation number be now? Now remember what's happening here is it has gained an electron, So is this oxidation or reduction or what's going on here? So what is oxidation? Okay, if you couldn't figure it out that way, let's look at this one. Here is sodium. Sodium has 1 electron like this. It's an element uncombined. So what's its oxidation number? Okay, when it bonds or it goes into a compound, it will form Na+. It will lose that 1 electron. So this is loss of electrons. So is that oxidation or reduction? And what happens to the oxidation number here? So pause the video now and make sure you have the right definition for oxidation. Okay, so hopefully you've seen that this is an element uncombined, has an oxidation number of 0. And when it loses electrons, it becomes +1 in its oxidation number. So oxidation in terms of oxidation number, oxidation is an increase in oxidation number. Okay, so here we've lost an electron, so it's oxidation, and the oxidation number has gone up. So that's what happens when we oxidize things. All right, so that is the first part. Let's look at the second part. There's a little blurb here. I'm not sure if there's that important here, but we'll read it anyway. It says the 2019 Nobel Prize for Chemistry was awarded to 3 scientists for the work in developing a rechargeable lithium-ion batteries for use in modern devices. So here is what one of these looks like. It says the balanced equation for the reaction that takes place when one type of lithium-ion rechargeable battery supplies electricity is as follows. So here we have a balanced equation. And I'm really glad this one came up because it's really unusual. So the first thing we're going to do, let's check what we have to do. It says assign, so that's what your job is, assign oxidation numbers and determine which element is reduced. So we're looking for reduction. All right, so the first thing I want you to do is I want you to pause the video and I want you to write that. I want you to go ahead and rewrite out the equation first of all. So this equation here, I want you to rewrite this out. Pause the video, do that now. All right, this is what you should have written down here. It was lithium carbide, so LiC6, and we're adding to that cobalt oxide. Very strange situation to see COO like that, cobalt oxide. You don't see that very often. And we're combining to make C6 carbon plus Li. What is it? COO2. COO2. Okay, so the next thing you had to do was assign oxidation numbers. Now I'm going to show you something here because there's something really funny here. Okay, something that maybe you didn't practice one of these in class. It's quite a tricky one if you were doing this in real time. So I just want to show you this. I'm going to show you how to do this first substance, lithium carbide. Okay, now lithium is in group 1. So it can lose one electron, and we know the rule for lithium, it's always +1. Any group 1 element is always +1 oxidation number. +1. Now, if we put that up top here, +1, and we work out the totals, we know the rule is for any neutral compound, the charges must add up to 0. So that means to make this add up to 0, the charges on the carbon have to be -1. But there are 6 carbons. So that's crazy. How can 6 carbons have an oxidation number of -1? This is why I said this was really unusual and really interesting. But what we're going to do is take that -1 and divide it by 6 to get the charge on each carbon, the oxidation number. The oxidation number on the carbon is -1/6. That's really strange and very unusual for a leaving cert chemistry question to ask something like this. Normally the numbers are nice and they work out really nice, but just so you can see that they don't always have to be whole numbers, okay? They usually are, but in this case, they're not. So it's quite a strange one, all right? So I just wanted to show you that. You should be able to go ahead and assign oxidation numbers to the rest of these. So pause the video and finish this off now. Okay, so oxygen, we know the rule for that is it's always -2. There are 2 oxygens, so that gives us a total up top of -4. And this is a neutral compound, so it must add up to 0, which means the cobalt must be +4, and there's only one of them, so the oxidation number of cobalt is +4. Over here, this is an element uncombined, so this is 0. And then over here, we've got -2 again on the oxygen, which gives us -4 up top. The lithium has to be +1 because it's in group 1. It can only give away 1 electron, so +1. And again, the neutral compound, they must add up to 0. So what can I make the cobalt be so that it adds up to +0? Sorry, it adds up to 0 here. Well, hopefully some of you have spotted that has to be +3. All right, so what I want you to do is I want you to use arrows underneath to show oxidation and reduction happening. Okay, so if you know what I'm talking about, pause the video and do that now. Okay, if you don't know what I'm talking about, I'll show you what I mean. Well, let's look for what's changing. So elements on the left, how have they changed on the right? Okay, so across the arrow, which ones change? Okay, so I'm seeing carbon is going from -1/6 oxidation number to 0. Okay, so each carbon has lost electrons there, lost electrons. And they lost 1/6 of an electron each. That sounds silly, but remember, this is just really an accounting technique. Oxidation numbers, they're just ways for scientists to track what's going on, what's been oxidized, what's been reduced. And then, so that's lost, so that's oxidation. That's not what we were looking for in our question. If we go back to our question here, read it again. It says, determine which element is reduced. So let's find what else is changing. Well, here in blue, I'm seeing cobalt going from +4 to +3. So that means it's gaining 1 electron, gaining 1 negative charge. And that means that this is reduction. So there we have our answer. It asked to identify which species was being reduced. So just with a bullet point, define which species has been reduced. Okay, so here it is cobalt is being reduced. So just to summarize for yourself at the end, cobalt is being reduced. All right, let's look at the next question. Identify which element acts as the oxidizing agent. So you must know what happens to the oxidizing agent itself. So this is part 4. And we're asked which substance is the oxidizing agent. Okay, so go ahead, pause your video, examine your balanced equation above and figure out what the oxidizing agent. All right, so this should have been really easy for some of you because you know the rules. What happens? Oxidizing agents, they themselves, they cause oxidation, and in doing so, they get reduced. That's the rule. Oxidizing agents get reduced. And we just said that cobalt has been reduced. So the oxidizing agent has to be cobalt. Well done, we got that right. Cobalt is the oxidizing agent because it got reduced. If you were looking for the reducing agent, you'd be looking for the thing that got oxidized. Next bit. Using oxidation numbers or otherwise, balance the following redox equation that occurs when a lead acid rechargeable battery supplies electricity. So here we've got a new equation and we have to use oxidation numbers to balance it. So again, the first thing you're going to do here is you're going to rewrite out the equation. Okay, you're going to rewrite out the equation. So this is what, part 5. So part 5, we're going to rewrite out the equation. PB plus PbO2 plus H plus give you Pb2 plus H2O. So I'm going to get you guys to pause the video and assign oxidation numbers now. Okay, so assign oxidation numbers, we should have got Pb is an element uncombined, so it's 0. In this case, oxygen is -2. So up top, the total for oxygen is -4, and that means that the lead is +4. So this lead, this second atom of lead is +4. And then this here is an ion. So the oxidation number equals to the charge on the ion, +1. Here's another ion, oxidation number equals to the charge on the ion. So that's +2. And then water, you probably know, learned off at this stage, is -2 on the oxygen, +1 on the hydrogen. Okay, so the next step is we're going to identify oxidation and reduction. Pause the video and do that now. Okay, so hopefully you guys have seen that this lead here, Pb, is going from 0 to +2. So in that case, it has lost electrons, loses 2 electrons. Okay, so it loses 2 electrons, and if it loses 2 electrons, that's oxidation. All right, with reduction then, we're seeing that the other thing that changes is the other lead, this Pb. This Pb is going from +4, and it's ending up as +2. So this here is gaining 2 electrons. And that is reduction. The next thing we're going to do is clarify what's going on. So Pb, and this is the Pb0, loses 2 electrons to become Pb +2. I want to pause the video and write about the other thing, the thing that gains electrons, how many and what does it become. Pause the video, do that now. Okay, so in the second bullet point, we're saying Pb, and this is when it's in its +4 state, gains 2 electrons to become Pb +2. The next thing we've got to think about is the ratio of these things, in terms of how many electrons are lost and gained. The ratio is 2 electrons lost to 2 electrons gained, or in its simplest form, this is a 1:1 ratio. So the electron transfer is already balanced. This thing is losing 2 electrons, this thing is gaining 2 electrons. So this is the right amount for each other. So in other words, there's a 1:1 ratio. So up here, these numbers are going to stay as 1s. So once we've got that, then it's just a matter of balancing out the rest of it by inspection. So these two things, the electron transfer is balanced now. So that was nice and easy. And then you just balance the rest of it. So what I'm going to do is I'm going to go ahead and I'm going to rewrite it down here so that it's less messy. I'm going to write Pb plus PbO2 plus H plus to give Pb2 plus H2O. Okay. Now, the first thing I'm going to do is take what I know from up here, that this here has to be a 1:1 ratio. It has to be one of the oxidizing agent and one of the reducing agent. The electron transfers have to balance, and then I have to figure out how to balance the rest of it. All right, well, the first thing to notice is that on the left now I've got 2 PBs, and on the right I've only got 1. So I'm going to go ahead and I'm going to put 2 here to balance that out. That should be fine. Now I've got 2 atoms of lead on the left, 2 atoms of lead on the on the right. Check my oxygens. Here I've got one oxygen on the right and I've got 2 oxygens on the left. So I'm going to go ahead and I'm going to change this to a 2 so that I balance out my oxygens. And now I've got my hydrogens at the end. I've got 4 hydrogens on the right now, and I've only got 1 on the left. So I'm going to go ahead and place a 4 here to balance it. All right, that's it done, guys. Of course, we don't really need to write the 1. So if you did not write them 1s, then that's fine. That would be your final balanced equation. If you need to see that process again, if that's not really making sense, no problem. Pause the video, go back and watch that process again until it makes sense. It should make sense. Again, what were we doing here? This is the biggest and hardest thing here, is to balance the electron transfer. The things on the left of the equation that are providing and that are taking the electrons, they have to balance each other for the number of electrons. There was a nice 1-to-1 ratio here. So that just means that those 2 things have to be 1-to-1, and then everything else you just balance by inspection or by the old method that we learned to balance an equation. All right, guys, that's that. All right, last bit, and this is a tricky little bit, last few marks. This is for you guys to think about. It's not that hard, but thinking outside the box. It might not necessarily be something you've talked about in class. It said here, why is the recycling of batteries desirable? So we all know about batteries. We all have one in our phone, and you know, like, you don't throw it in the fire. You don't really want to send it to landfill. But what are the reasons for that? Now, if you're stuck, look at the stuff that's in them. Look at these, look at what's in the battery. This has to be in the battery if this is the reaction that happens. So does this. What's the problem with throwing this stuff away? I mean, it's pretty straightforward. It's easy to get the marks. There's lots of answers here. But somebody might look at that and go, oh, I didn't do that in class, just leave it. I don't know that. But you have to just, sometimes in the chemistry paper, especially those last 3 marks, if you want to get those H1s, H2s, you have to be having a little go. Think outside the box here. What would be the problem with dumping batteries? Well, why do we want to recycle them? Pause the video, write down an answer. Okay, the first thing to note is that lead and cobalt, so PB and CO, these things are what we call heavy metals. Okay, heavy metals. That just means that they've got a large atomic number, or large mass number, atomic mass, and they don't, you know, they don't decay very readily. They're pretty stable, and if you dump them in the environment, you get them into your body system, they stay there, they collect there. So that's what problem with heavy metals. So if you didn't know that, maybe then you can have another go at answering it now. Okay, so what we're talking about is we're talking about recycling batteries. Why is this a desirable thing? Okay, I'm going to give you a couple of reasons, because there's lots of different possible answers here. But you basically, if you said something like to avoid pollution, or so not to pollute, something like that. So avoid pollution in general, because you don't want to just throw anything away. Anything you can reuse, you should try and do that to avoid pollution, especially to avoid pollution by heavy metals. We don't want heavy metals in waterways. We don't want them in soil. Heavy metals damage health. Metals like lead, especially heavy metals, damage health because they're toxic. Damage health, or you could say that they're toxic, especially lead. So you don't want them in your waterways. You don't want them in your food sources. Okay. Another point of note is, well, there's big issues with those chemicals that are really important. We want to keep making batteries. There's not an unlimited supply of them. So if you didn't, what could you write down as an answer for that then? You can't just keep using this stuff forever. That's not sustainable. Can't just keep digging out new cobalt or new lead or new lithium. You're going to run out eventually. So can you write an answer about that? Pause the video and do that now. Okay, so you could say metals, lithium / lead / cobalt, cobalt are in limited supply. So you don't just want to always just throw everything out. If you can reuse the stuff that's in there instead of getting rid of it, limited supply, then that's it's more sustainable. You can't just keep dumping everything. And obviously they have an economic value. So heavy metals have an economic value. So why dump them? So there's lots of different answers you could get there, guys. It's quite easy to get the marks, but you have to have a go with it. If you write nothing, you definitely can't get any marks. So that's why recycling batteries is desirable. Right, lads, I'm going to leave you with the official marking scheme for this question. if you want to just check back over your answers and check the key points that you need to hit, the language that you need to have described in there, that's all there. And that's it, guys. I'll see you in the next one.